There we go.
Is it push it out?
Yes.
Good morning, good afternoon, and good evening. My name is George Gu, President-elect of ISPI, the International Society for Performance Improvement.
I know one that was always frustrating to me is sometimes with a client, the assumption was training was going to solve the problem. And they really did not consider, other options.
So, and the sort of obsession or almost cult of leadership, which has formed more recently, worries me somewhat.
Because I sure know that I do. I remember the first time I did my exam and I failed miserably. Like I took a turn at a very high speed in a very low gear.
To me, what it is representing is the fact that the world, as it moves faster, we begin to realize that it's far more chaotic than we thought.
And quite simply, when I say delivery method, I mean, is it classroom? Is it virtual instructor led? Is it e-learning?
This is a learning trend survey report. Every year, Tier 1 surveys the industry.
Sometimes we do a deep dive into a particular interesting piece like memory or something about, say, psychological safety. And
what the accomplishment is guides us to look for the appropriate behavior. And then finally, we arrange all kinds of things, or there are all kinds of things in the environment to support the behavior, to produce the accomplishments.
But listening here is hearing the intent. Our clients are not always skilled at articulating their meaning, but we really need to hear what the intent, the message behind.
Work was somewhat redefined in real time, and so there's some interesting stuff in there about that as well.
So human systems integration is the transcultural and transdisciplinary technical management process to ensure that human elements of a system are addressed.
And another quotation is with HRBPs. They work closely with the BPs and they're keenly aware of the business needs. So this is a theme that I found throughout all the interviews.
So if it starts with number of, it's probably a quantity measure. And those are called efficiency measures. Sometimes, to determine whether a value is efficient.
Despite what vendors will tell us, I understand that Donald Clark did one of these quite recently, and so I'll go some way to being more contentious than Donald Clark.
We were going from behavior, which are mean, to accomplishments, and this is a big change in our influence, and Tom Gilbert basically helped us in that thinking.
Senior leadership desire to see impact and ROI of major investments. It is not going anywhere. We have been singing this song for so long, and it's just not changing.
Now, I'm writing all of this because I'm trying to affect the people that do analysis. And if you're going to be in a project, this is my adapted version of ADDIE, and this is what I've been using since the early 80s.
I think for when people are going back, you really have to understand that employee experience, right? So you have to understand and design that employee experience.
And we basically set up a department, and it wasn't a training department, it was a performance improvement department with the bank, and that was another.
So if you have a company or work for a company that may want to have a chance to market themselves at the conference, please pass that along.
Now, one of the pivotal things that's really helpful is if your customer is included, this becomes very eye-opening. So if you involve your customer in the...
We lose about 80% of what we hear within 48 hours of hearing it.
We must go to history. And it was born by the Lions, it was created by the Lion.
When you think something like this is true, you end up making adjustments to your learning strategy, start creating solutions which are more tuned to this. So you may have maybe micro-learning.
Bring your family, stay on past the conference, and see all there is for Williamsburg to offer. Before I close, there's also
plus the other parts of the systems that have to change have their own curves. Plus, we're living in a world of volatility where there's a lot of changes occurring all around us.
So take a moment and think about the last change your org went through. And if you're so inclined, you can tell us if you're called in immediately when discussing.
So that's where I'm starting from. So having said that, let's look at a little bit of history.
And see you next Saturday. Have a fabulous weekend. Thank you. Signing off. Good morning, good afternoon, and good evening. Welcome to ISPI Live number 29. My name is George Gu. I'm the president-elect of ISPI, the International Society for Performance Improvement. For over 60 years, ISPI is dedicated to improving organizational and individual performance through evidence-based research and practice. Last week, we were very honored to have Dr. Stella Lee from Calgary, Canada, to present the rise of AI in L&D. It was a very interesting topic. Please go back and look. This week, we're so honored to invite Veronika Shestakova to share with us, again, AI topic, best practices and biases of artificial intelligence. Veronika Shestakova is a certified performance technologist. She got her master's degree in finance, specializes in risk management. Veronika is a practice leader at the Hale Center. She has worked with European Exchange, the Eurex, and HSBC Bank. She's experienced research, statistical analysis, modeling, including artificial intelligence models. She has presented at ISPI's annual conference on the hidden costs of automation, on critical thinking, and biases in AI. She has also published articles in Training, Performance Express, and Performance Improvement Journal. She's also associate editor for the Performance Improvement Journal and also a member of the ISPI CPT Credential Committee. During her presentation, Veronika will have some interactions with the audience. Please type your answer in the chat area as usual. So Veronika, the floor is yours.
Hello, everyone, and thank you, George, for a great introduction. So welcome, everyone, to my presentation on best practices and biases of artificial intelligence. We have several objectives for today. First is I would like for you to have a better comprehension of artificial intelligence. Most likely, you have already encountered AI in your daily lives. Some of you may have encountered AI in your professional life. If, for example, your organization has implemented AI model into its business processes or is thinking of implementing AI into its business processes, and you are wondering, well, what is artificial intelligence and how AI is created? Well, this is a presentation for you. During this presentation, we're going to talk about what is AI, and then we're going to discuss on a higher level how AI models are being built. With that, we're going to get a better understanding of potential sources of bias in AI and how biases are introduced into the model development process. And after that, we're going to discuss some best practices to mitigate such biases in AI. So what is artificial intelligence? Artificial intelligence is a simulation of human intelligence in machines that are programmed to think like humans and mimic their actions. AI is specifically used to replace or augment human decision-making and problem-solving. There are lots of different definitions that are connected to AI, such as artificial intelligence, machine learning, deep learning, neural networks. And I hear a lot of people using these terms interchangeably. And even though they are all connected to each other, they're not quite the same thing. So let's clarify the definitions for those concepts. First of all, artificial intelligence. It is a technique which enables machines to mimic human behavior. And machine learning is a subset of artificial intelligence, and it uses statistical methods to enable machines to improve with experience. A very high-level description of a machine learning model would be that you upload thousands or millions of data points into your machine. The algorithm would run through this data multiple times, and it's going to learn every time through the experience about this data. And then with this experience, the machine is going to be able to make predictions or certain decisions. And then we have a deep learning. Deep learning is a subset of machine learning, and it makes the computation of multi-layer neural networks feasible. So the deep learning is using programs such as neural networks. And the neural networks were inspired by actually neurons in our brains, right? How they're making connections to each other, how we are processing the information and putting pieces together. So an example for a neural network model would be like a facial recognition software, or like the software that, there's a new Google search option when you open your camera, you point to an object, and then Google is going to search for this object anywhere on the internet. Well, this is an example of a neural network. AI has impact on every industry. Financial and banking industries were one of the first industries that started using AI technology. So right now, if you want to purchase a car and you're applying for a car loan, most likely your car loan application is being reviewed by an algorithm, and the decision is made by a computer. Facial recognition, right? We just talked about it, like the neural network models. Most of our phones, we can unlock on our phone using our face, right? When you're watching Netflix or purchasing things from Amazon, and then you get a recommendation on what to watch next, what to purchase next, these are all AI models. Or like when you have a virtual assistant in your home or in your phone, this is an AI model. Medical field is one of the biggest, going to be one of the biggest users of AI models in the future. And all the medical tests that we're submitting, right, they are all going to be reviewed by the computers, and maybe some of the medical decisions are going to be made by the computers as well. So I have a question for you. Please type your answer in the chat. Do you feel that AI is impacting your daily life? And also, I would like for you to share if you had any interesting experiences with an AI, like either in your personal or professional lives. Like personally for me, I just learned about a really cool AI program. And this involves, I think it's something called like an AI virtual assistant. So with the pandemic, right, we get lots of virtual meetings, and some of those meetings happen to be at the same time. Well, this AI program allows to connect to all of those meetings. So for example, if you can't attend a certain meeting, the AI program is going to connect to say a Zoom meeting for you, is going to take notes during the meeting, and then it's going to summarize the notes for you. So please share in the chat if you have any interesting stories with AI or experiences with AI. So while you're typing your answers, let's continue with our presentation. So there are lots of arguments for using automation. AI can improve work productivity, reduce human error, automate repetitive tasks. AI makes work safer as it avoids putting people, money, or assets at risk. And because we hear so much about AI recently, many people tend to think that AI is a new concept. However, one of the early AI researches have been published in the 1950s. And one of the first people to propose an AI concept was Alan Turing, a British mathematician. Turing suggested that humans use available information as well as reason in order to solve problems and make decisions. So why can't machines do the same thing? Well, I think this is a great question. However, in the 1950s, the computers simply were not ready. Computers lacked a key prerequisite for intelligence. They couldn't store commands. They could only execute them. In other words, computers could be told what to do, but couldn't remember what they did. And second, computers were extremely expensive. In the early 50s, the cost of leasing a computer ran up to $200,000 a month. So by the 1970s and 1980s, finally, computers became faster, cheaper, and more accessible. We start seeing computers appearing in the workplaces. However, computers simply could not store enough information or process it fast enough. Remember, right, when I talked about machine learning models, the computer needs to be able to store and process thousands or millions of data points. And in the 80s, the computers were still not powerful enough for that. In the 90s and beginning of 2000s, computers were finally able to catch up, and particularly the computer storage and computer processing capabilities. So, and then in the 2000s, we now live in the age of big data. We produce millions of data every day. And now our computers are so powerful that they have the capability of storing and processing this data. So that is why right now we really see the development and implementation of various machine learning models as well as the deep learning models. So for us to understand how biases can be introduced into an AI model, let's first understand on a very high level how an AI model is being built. Well, first of all, you start with the problem that you want to solve or a process that you want to improve. And then after you define the problem, you go onto the data collection step. So this is when you pull out all the necessary information. This can be either historical data from your own organization, or this can be like a market data that you purchase from a third-party provider. After you collected your data, then you move on to the data preparation step. So this is an extremely important step. And when I was working with the model developers at the bank, they would tell me that they spend 70 to 80% of their time preparing the data for model development. And what does it mean? Well, it means looking at the data and understanding what kind of data did you get? And then how can you use this data to create a model that's going to answer your problem? And then also it's cleaning the data. So removing any outliers, missing values, maybe highly correlated values from your data set. And you need to remember that the data is the basis that your model is using and is being built. So really the quality of your data is crucial because depending on what kind of data you use, this is the kind of model and the quality of decisions and predictions that you're going to get in the end. So after you prepared your data, this is when you move on to the model development and evaluation stage. So this is when you decide what kind of AI model do you want to use? Do you want to use this model or this one? Or you actually want to use a combination of several models? And then this is when you choose what kind of parameters you want to be using, and also how you're going to be tuning those parameters to improve the performance of your model. So after you're done with your model development, this is when you're testing the performance of your model in the evaluation stage. So what can happen, especially in the AI models, is that you can overfit your model to the data. And what does it mean? Well, it means when you're working on the development in your model, you're using a training data set. And when you're choosing what kind of parameters you want, you can fine tune your parameters to fit perfectly to your data. And your model is going to have an amazing performance. However, there's one problem with that, is that it's going to have an amazing performance specifically for your data set. But then in the future, right, when you implement the model, you're going to get the new data. And this is when you can see the drop in the performance of your model. That's why you're using a new data during the evaluation stage, and you're testing the performance of your model and see if the performance stays the same or if it drops. And if it drops, that means you need to retrain your model. After you're done with the evaluation, finally, you are able to move on to the model implementation stage. So, and after the model implementation, there's another final and very important step, which is the model monitoring stage. And what does it mean? Well, depending on the risk factor of your model, you need to decide the frequency, how frequently you want to monitor your model. So, for example, if this is an AI model that is implemented by a major medical hospital, and you're using this model to evaluate, let's say, test results for your patients and determining course of treatment. Well, if the model goes wrong, this can have a real life or death impact on your patients, right? So this is a very high risk model. So that means you need to monitor your model more frequently. And what does it mean? Well, it means testing your model if it still performs the same as it's supposed to be, or you would need to analyze what kind of target population you have. Or for example, if it's a financial model and you have a new regulation issued for your bank, you need to be adjusting your model. So this is a step when you want to retrain your model and go back and to see what needs to be adjusted within your model. And before we move on about talking about different types of biases, what I would like to say is that bias can exist in many shapes and forms, and it can be introduced at any stage in the model development pipeline. At a fundamental level, yes, George?
Yeah, there are some questions, some answers to your previous question. Some people.
Oh, that's great.
Said, yeah, there's some A and there's some C's about somewhat, and some felt that already impact their life. Some say it doesn't much impact my life much yet, but I read a lot about is how impacting our world, and not all chatbots are equally effective. Yes, when I did the search for my car, suddenly I found myself getting unsolicited ads for cars and financing options. And
well, this is definitely interesting, right? Did you ever experience something like, I was talking the other day to a friend about the vacuum cleaners, and then I pull out my phone and I get the ad about a vacuum cleaner on my phone. So
yeah, once you're hooked forever.
Yes.
once they got you forever. And some robocalls are sometimes very human-like, and also many clients have not paid attention to the quality of the data over years. It can be a mess to clean up, and many have no idea how messy the data is, and and there's a question, how can AI be used to clean the data? So anyway, just a little bit add. Next week, we're going to talk about data security, cybersecurity over this AI age. So next week is also a good topic, but keep on going, please.
Thank you, George. Yes. So before we start really diving into different types of biases, what I would like to say is that a fundamental level, bias is inherently present in the world around us and encoded into our society. We cannot directly solve the bias in the world. On the other hand, we can take measures to weed out bias from our data, our model, and our human review process. So let's talk about different types of biases. And these are the biases that have been identified in this research paper that I have cited here on the slide. And they are a historical bias, representation bias, measurement and aggregation biases, evaluation bias, and deployment bias. So this is the same type of model development process that we saw in the previous slide. However, now we can see how different types of biases can be introduced at a different stages of the model development. So, right, remember that we start with the data collection step in the beginning. And this is where you're either using your historical records or market records or any other type of data. And this is where you can have a historical bias. So for example, if you're using a hiring data that has some historical biases encoded in it, you're going to reintroduce the same type of bias into your model. Then you also, maybe the data that you're using reach only a portion of the population, and your targeted population actually not properly represented in your model. This is when you can have a representation bias. Next, when you're deciding what kind of, how you're actually going to measure certain things, what kind of parameters you're going to be using, can be a measurement bias. Or when you're choosing what kind of model do you want to use, and you say, okay, well, I think we can use this type of model to make decisions for various population. Well, this can be, and if your populations are distinct enough that one model is not going to fit all of them, this is going to be an aggregation bias. And even after you build your model and then you're testing the performance of your model, however, your testing data has also some biases built into it. This can be an evaluation bias. And even if you avoided all of these potential risk factors during your model development process, however, your implementation of the model is incorrect, you can have a deployment bias. And by the way, you can have more than one bias built into your model. So what we're going to do, we're going to talk through each of these biases, understand how they work, and we're also going to discuss some real-life cases when these biases occurred in the AI models. So first, we have a historical bias. Historical bias occurs when there is a misalignment between the world as it is and the values or objectives to be encoded and propagated in the model, meaning that the data that we're sampling is misaligned with the objective of our model. So this is a very interesting case that happened with the Amazon several years ago. And we all know Amazon, right? So it's a major tech giant company. And the goal of this algorithm was to build a hiring algorithm that's gonna, let's say, if there's a tech role opening and people submit hundreds of resumes, the algorithm is gonna look through all of those resumes and choose top 5 candidates. However, during the model evaluation stage, the model developers identified that the Amazon algorithm taught itself that male candidates were more preferable than female candidates. And it penalized resumes that included the word women's, for example, like a women's club champion, whatever, or it downgraded graduates, let's say, of a women's only colleges. So what happened is that when the Amazon was creating this model, they used 10 years of historical hiring data to build this model. So like over the past 10 years, all the resumes that were submitted to the Amazon, they used them to build this model. However, the tech field, as we know, historically been a heavy male-dominated field. And when the algorithm was looking through all this data, it taught itself that male candidates were more preferable than female candidates. And if we look here on the historical data on the right, we have a global headcount for the major tech companies such as Amazon, Facebook, Apple, Google, and Microsoft. And we can see that overall, 60 to 70 of their employees are male. And then if we look at the tech roles, 70 to 80 of their employees are male. So this is exactly what happened with the Amazon, right? That the algorithm taught itself that male candidates are more preferable than female candidates. So model developers were trying to remove this bias from the algorithm. However, they were still not confident that the algorithm is not going to find a different way to teach itself to discriminate against certain applicants. So actually, Amazon decided not to use this model entirely in their hiring process. All right, next we have a representation bias. And it occurs when the training data set underrepresents targeted population. So it can arise for several reasons. First is that the sampling reached only a portion of the population. So for example, I'm using the data from my model that was collected using a phone app. Well, you're automatically underrepresenting people, populations, let's say, that do not own the phone or do not have the app that you're using to collect the data. Another reason how you can have a representation bias is that the population of interest has changed or is distinct from the population used during model training. So for example, if I'm building a model to analyze the population in Chicago, but my training data is the one that was collected 10 years ago, well, the population in Chicago 10 years ago can be quite different from the population today. So my training data does not properly represent the population in Chicago today. So this case study is a very interesting research called gender shades. And the researchers in this study, they wanted to find out if facial recognition worked well or if results changed based on gender or skin type. So they tested 3 major facial recognition software companies such as Microsoft, Face++, and IBM. And the data set that was tested included images of over 1,000 parliament members of top 10 countries based on the representation of women in power. And to get a range of skin types, 3 African countries and 3 European countries were chosen. And here we can see in this table the actual results of the study. And we can see that overall 3 companies did really well in recognizing faces of the lighter skinned males, right? We can see that Microsoft had 100%, IBM 99.7%. But they did pretty well in recognizing faces of lighter skinned females. Then we can see some performance drop in the recognizing faces of darker skinned males. However, the real problem occurs right here, where we see a real performance drop in recognizing faces of a darker skinned females. For the IBM, the gap was 34%, right? So from the best performance of 99.7, and it dropped to 65%. So one of the reasons why this happened is the lack of diversity in training images and benchmark data sets. So right, if you remember when we talked about the model development, you're building your model using a training data set. So if your training data set underrepresents the population, and then your benchmark data set, the one that was used to test the performance of your model, does the same thing, this is the kind of issues that you're going to get in the end. So let's continue with this example onto our next type of bias, and it's evaluation bias. It occurs when the evaluation or benchmark data for an algorithm does not represent targeted population. And as I said, right, the training data is used to build a model, but then you're testing your model with using the benchmark data, which is separate from your training data. And this is when you can really see some performance gaps of your model. So here's a case study for this. ImageNet data is a popular source for research and computer vision. So many organizations that are building, let's say, image recognition or facial recognition, they could use an ImageNet data for their training data or evaluation data. The problem is that more than 45% of the ImageNet data come from the US. Most of the remaining data come from the North America and Western Europe. China and India together contribute just 3% of the ImageNet data. Our next type of bias is a measurement bias, and it occurs when data are incorrectly labeled or categorized. And the chosen set of features and labels may leave out important factors that may lead to inaccurate performance. So this is a very interesting research that was done by a group of researchers. And in this research, what they wanted to identify is what factors are most predictive of a stroke. So patients in the emergency department can be difficult to diagnose. And researchers wanted to identify factors that would help to identify patients in the emergency room who are having a stroke or at a high risk of an impending stroke. So they use data from a large academic hospital, and it's the emergency department, to predict a short-term stroke risk. And as a predictors, they use demographic data as well as any prior diagnosis in the electronic health record system. And here's the result, right? We have the factors. So when we're looking at the factors most predictive of a stroke, first we have a prior stroke, which makes sense, right? The people that had a stroke before, they are in the higher risk of having a stroke in the future. The second factor was a cardiovascular disease, which also makes sense, right? It's all connected to the heart. So you at a higher risk again of having a stroke. But then the next 4 factors are very questionable. We have accidental injury, benign breast lump, colonoscopy, and sinusitis. So this doesn't quite make sense, right? Well, how is sinusitis, for example, is connected to a stroke? Well, what happened is when the researchers were creating this model, they need to define a measure for a stroke, right? Well, how did they get even a measure for a stroke in the system or in their data? Well, it was from the people who were experiencing certain symptoms. They went to an emergency room, they saw the doctor, they got tested, and then they received a diagnosis that they had a stroke. Well, this automatically excluded people that, first of all, did not have access to the hospital or emergency room. They decided not to go see a doctor. And also another reason that was cited in the research is that the patients often set an agenda and select symptoms that they want to complain about. So for example, if they're experiencing multiple symptoms, but then they're going to see a doctor, they're only going to focus on one symptom and then not talk about the others. So, and this also research, I believe, demonstrates a very important factor for any researchers or model developers that are developing an AI, or people that are actually implementing AI models, is that it is very important, even crucial, to look at the results produced by the model critically and ask yourself, do these results make sense? Because like in this example, right, we see that, yes, two factors make sense, but the others are very questionable. So you need to ask yourself what happened, and you need to identify a problem. Because we as humans tend to believe that computers are all-knowing, they're very smart, they're fair, they're making the right decisions. So we tend to take a side of computer in the decision-making process. However, as the experience shows us right here, is that computers are not always making the right decisions. So we as model users, for example, if we're implementing an AI model, we need to look at the results produced by an algorithm critically and apply our expert judgment to them. Next, we have the aggregation bias. And it arises during the model development when distinct populations are inappropriately combined. It can lead to a model that is not optimal for any group, or a model that is fit only for a dominant population. And this is an example of one size fits all. So if your model scores aren't calibrated for each group, it's likely that you're systematically overestimating or underestimating the probability of the outcome for one of your groups. So here's an example for that. Is that studies show that diabetes patients have different levels of HbA1c. It's a chemical that is widely used to diagnose and monitor diabetes, and they have different levels of it across ethnicities and genders. So that means the different groups will have different probability distributions. And a single model to predict complications is unlikely to be best suited for any group in the population, even if they're equally represented in your training data. So to address this issue with fairness, a best practice is to make sure that your predictions are calibrated for each group. And last, we have a deployment bias. Deployment bias arises during the implementation of the model, when the model is used inappropriately or its results are misinterpreted. So in other words, if the model's intended use is different from the way it is used, deployment bias occurs. So you can have an amazing model. However, if you implement it incorrectly, this is when you can have a deployment bias. So this is a very interesting case when the model had a great accuracy and was able to discriminate between high and low cost patients. However, the problem arose when this model was used to predict healthcare need instead of a healthcare cost. So high-risk care management program was designed to identify patients with additional healthcare needs and provide healthcare resources to them. Well, especially in the US, we all know that additional healthcare resources mean higher costs. So people that were implementing the model said that the high cost must mean the person is more sick, right? That is why they decided to use a model that was very good at estimating the healthcare cost to predict a healthcare need. So the deployment of the model was biased. And the algorithm falsely concluded the groups that spent less on healthcare were healthier. And as a result, those patients needed to be twice as sick in order to qualify for healthcare benefits. So why does bias in AI matter? Well, first of all, algorithms can amplify biases. Biased AI systems have immense impacts in our lives. AI systems can unfairly allocate opportunities, resources, and information. AI systems can infringe on civil liberties while also reinforcing existing prejudices. On a larger societal level, when unchecked, AI systems can solidify and amplify societal discrimination. Another reason why bias in AI matters is that technology is power, and with that comes responsibility. And I find this statistics very powerful. This is on a global level. 64% of the population have internet access. 7% of the population have college degrees, and only 0.5% know how to code. Just think about it. This 0.5% are building models that are deciding if you're going to get a mortgage for your new home, if you're going to get access to the healthcare, if you're going to get hired or fired from a job. So as model developers and model users, we have this immense responsibilities to identify potential biases in AI models and also do our best to control and mitigate them. So we talked a lot about like different risks and biases in AI, but what I still would like for you to remember is still AI can be immensely powerful and also beneficial to organizations. And also tackling bias in AI can also bring multiple benefits. So, and the benefits includes things like strong brand reputation, improved value proposition, stronger competitive position in fast-paced industry. So for example, if you're in an industry where you have lots of competitors and you're offering a relatively similar product, with an AI, you're able to make, you will be able to make some better quality decisions in less time. Well, this is going to give you a better competitive position in your industry. AI improves productivity, and also tackling a bias in AI is a good risk mitigation technique. So if your organization is thinking of implementing an AI model, or they have already implemented it, here's some of the questions that you may ask to prepare some of the best practices to mitigate biases in AI. First is, what assumptions is the algorithm based on, and what are the limitations and potential biases of those assumptions? Remember when we talked about the AI model development process, we first start with identifying what kind of problem do you want to solve? Well, what can happen is that you assume that this is the problem that we have and this is what we're trying to solve, but in reality, the problem can be quite different. So you need to clarify with all people involved in AI model development that you're, what kind of problem you want to solve. You want to clarify the algorithm's purpose and algorithm's functions when it's going to be implemented. Next is, what data set is the algorithm trained on, and what are the limitations and potential biases in the data set? We talked a lot about the importance of the kind of data that you're using when you're training or building your model, and also what kind of data that you're using to test the performance of your model. So best practice here would be to document the creation and use of the data set, and also to ensure that the purpose of the data set aligns with the AI intended use. And also, even after your model is implemented, and for example, you get some problems with an AI decisions, you can go back to your data sets and check if the data sets had a similar problems encoded in them. Next question is, what criteria will be used to measure the effectiveness of the algorithm? So you want to ask yourself, does your solution increase productivity through automation of routine decisions and augmentation decision-making workflows? Is incorporating AI in the business model is going to reduce human errors and biases in your current decisions? So you need to be clear on why do you want to be using an AI model in the first place? And also clarify from the beginning how you're going to be measuring if the algorithm is doing what it's supposed to be doing. Next question is, what actions have been taken to mitigate the negative impacts that could result from the algorithm's limitations and potential biases? So this is a place where you can play some what-if scenarios. So what if you implemented a model and it goes wrong, and then you identify that it went wrong? What are you going to do in this case? So for example, right, if you use an AI model in your association and the model was deciding if applicants are going to get certified or not, and you identify that the model been rejecting the applicants that actually should be certified, well, what are you going to do? Are you going to reach out to those applicants and ask them to reapply? Are you going to give them a certification? Or is there going to be some sort of human review step between the decision made by the algorithm and the actual decision issued to the applicant? A really interesting solution I found by one organization for this type of, to mitigate bias in AI, is one step of their certification was an essay. And the essay was graded by an AI algorithm. Well, what they did, they allowed an option for a test taker to see the score of the essay that was produced by the algorithm, and then the test taker can contest the score. So for example, if they feel that they did really well on their essay, but then they got a low score, they can say, I disagree with this score. So then this essay would actually go to a human reviewer, and then the human reviewer is going to give a score to this essay. A next question to ask is, what assessments have been made of the fairness of using the algorithm? So you need to look only not at the statistical performance of the model, but also you need to look critically at the results and identify if the model is biased against certain groups, or if it's reinforcing historical biases. So for example, if you're using an AI model to look through the resumes, right? People that are applying for a position in your organization. And then you identify that the model, again, is reinforcing some historical biases in your field. Well, you need to be very clear on what are some potential risk factors that can be introduced into your model. And you need to be prepared, again, to mitigate them. And what we talked in previous step, like in the what if scenario. And then the last question is, what human judgment is needed before acting on the algorithm's output, and who's responsible for ensuring the algorithm's proper use? So responsibility can be quite interesting in the AI. So if your organization built an AI model and implemented it and it went wrong, well, yes, your organization is responsible for it. However, if your organization hired a third party to develop an AI model, and then you implemented it and it went wrong, who is responsible for it? Also, another good practice to mitigate bias here in AI is perhaps to train people that are implementing an AI model, again, to look critically at the results produced by the model. So you need to train them to have a confidence in themselves to, when they look at the results and then they see an issue, that they're confident enough to raise a red flag and say, I believe there's something wrong with the decision made by the algorithm, and we need to check what went wrong. So to summarize, AI is a part of our lives and has an impact in every industry. AI can improve work productivity, reduce human error, and automate repetitive tasks. However, over-dependence on automation without proper oversight can reinforce and amplify biases present in our society. We, as model developers and model users, have responsibilities to make AI safe, ethical, and effective. We need to make the best effort to identify and remove biases in the model development process. We do not want to over-rely on the decisions made by the machine, and we want to enable evidence-based decision-making. And then important part is that we want to continue to reevaluate the performance of the algorithm as it's being implemented. We want to continue to identify potential risks in our model, and we want to reduce them. So if you're interested in learning more about potential biases in artificial intelligence and other interesting case studies, here are some of the book recommendations that I have for you. And I have another AI question. Another question for you is, how will the information I shared help you as a PI practitioner? So please share your answers in the chat.
Well, the audience are typing or thinking, and wow, Veronika, thank you so much. Oh, how many biases did you present? Like 7 or 6?
6.
6 biases in total. And I have my own questions there. I mean, I was amazed the magnitude of AI biases could impact our lives, you know. So my immediate question is, how does it applies to L&D when all these biases? What are the scenarios that will happen that more challenging? I mean, AI can cause even a mess, something like that.
Yeah, well, as I said, different AI models have different risk factors, right? Some only can cost you a lot of money. So, for example, if you're using it for, let's say, marketing purposes, and then it sends out all the marketing information to the wrong people, well, this is just going to cost you money and time. And also, developing an AI quality AI model is going to cost you also quite a bit of resources. Not only like human time and financial resources, but also like, as I said, some of the, and then you mentioned that AI models have some risk factors. So for example, if it's a financial model or if it's a healthcare model, this can only not cost you financial resources, but also even human lives.
During your representation biases, all those facial recognitions and between, I mean, the face company, I mean, the Microsoft, the IBM, that comparison also amazes me. And also China and India population combined only counts for like 3% of their database. So that really I mean, my question is, will those things that we have been fighting for since in the 1960s, 50s, 60s, 70s, you know, have a lot of social impact, like social justice and
yes,
and you know, women's rights and all that will come back again in the AI world? That's my question.
Yeah, yes. And what I also think is very encouraging, that more and more people identify that AI systems, models are reinforcing certain biases or problems that we had previously. And since researchers are recognizing it, there's more and more efforts to mitigate that. And yes, and then I didn't present every single case, but there are models that are used in the system of like if to decide if the person is going to be released early from prison, right? If the person is actually going to go to prison. So those are very important and critical models. So right now, with more case studies and researchers proving that there could be some biases present in the current AI models, people are paying attention to it. So there are more efforts to mitigate such biases.
Yeah. Also, as this will impact many, if not all, engagements going forward, since clients will try and use AI to help with customer experience while reducing costs. And also, Judy, she says we can promote critical thinking in the on the application of L&D in. I mean, AI on L&D. She says we can promote critical thinking, allowing examination, discussion, debate. If L&D focuses on obedience to a procedure, we disincent dialogue and critical thinking, which I found very true. It will help me coach clients in more critically questioning what they're doing. So, and also another question previously, how can we use AI? How can AI be used to parse and clean the data? You can respond to the comments or answer the questions.
I'm sure you can build a model for an AI to go through this data and identify, like the outliers and missing values. However, in my experience, for cleaning data step, it's mostly developers were using Python or any such coding algorithms to just go through this data. So this is a step when you do not want to give complete freedom to the computer, right? Because you really need to be able to understand what kind of variables you have in your data, and how you also how you're going to evaluate those variables and identify if there are certain problematic variables and how you're going to remove them, because within every data set, right, can be quite different. So if you build an AI algorithm that was using a certain type of data set, but then you're presenting data that was collected using a different method or different variables, I don't know if the performance of the model is going to be the same. So I would still take more control over the data cleaning step myself, and I would actually just write a Python code to look through this data.
Great, thank you. To our audience, please, Veronika asks us a question. How will the information I shared help you as a performance improvement practitioner? If you have any thoughts and comments, please respond in the YouTube chat area, and we'll relay back to Veronika. Veronika, I do have a question about that. And the PI, as a PI practitioner, do you think you have a lot of research and practice and experience in performance improvement? Do you think PI can be automated or AI'd?
Well, about the automation, right? A lot of people are being concerned, and not only in performance improvement, but in many areas. When I worked at the bank and when I was validating machine learning models, we also were concerned that, someone can actually write a model that is going to be doing all our job. But I think in the end, it's still important to remember that we still need the human judgment, right, to look at the processes and our expertise. So like our years of experience of doing this job, or different types of case studies that we encountered that may not be properly represented in the AI model. So even though there could be some implementations, there could be implementations of AI in the performance improvement field, I still believe that there will be need of our human expertise in performance improvement.
So at a larger scale, I mean, this is also more of kind of a social topic. I mean, of the society at a social science level. Do you believe AI will replace human in the future?
No, but what I do believe is that we as humans are gonna learn how to work with an AI, with like a partner. So we will need to get a better understanding of artificial intelligence, and we're also gonna adjust, right? I don't know, 30 years ago, we did not have our phones, but now it's irreplaceable part of our lives, and we're so connected to it and we're working with it. So what I believe is that coming into the future, AI is going to be taking more bigger part in our professional and daily lives, and we're going to adjust and we're going to learn how to work together with it.
The excitement, my experience, excitement and the fears came all together at the very beginning. Any new advancement of technology, pairs with excitement and some deep fear. I think AI is the same. Hollywood have a lot of, Hollywood have done a lot of jobs on AI and, AI. There's a movie just called The AI by Steven Spielberg many years ago, and also I, Robot, and Will Smith starred in it. So a lot of things, and also Robin Williams, and as a home servant or something like that. So, and it is so intriguing. But today's your presentation just I don't want to use the term that opened the can of worms, but it is, I mean, really provoke a lot of thinking. I mean, like last week with Dr. Stella Lee. So at the end of the session, it's just like we just got started, you know.
Oh,
because,
yes.
because it's such a topic of the future, but right now already happening around us, either in our social, life, or in the financial systems, in Medicare. I mean, anywhere is happening. I mean, without the deep fear I think most of the people have is that we don't know.
Yeah. Well, and also, as I talked about, right, evolution of AI and our computer technology, our computers have finally caught up and exceeded, right, our expectations. So they're so powerful right now. So that's why we really see right now real development and huge progress in AI. So, and as I showed in my today's presentation, is that there are certain risks associated with an AI. So of course, going into the future and some sci-fi future, right, as in Hollywood, we do not want the computers run free. We still want to insist on some controls and to identify what could be potential risks and how we can implement, again, our human judgment and control over algorithms and its decisions.
Tools are tools. I used the metaphor that in China, many years ago, they invented calculus. Is that calculus? I'm sorry, but anyway, now and then we have different ways, and then we have a calculator. We have what's that? And then we have computer. So I mean, our efficiency, work efficiency is coming up, but it's really increasing, but doesn't mean that our creativity will be replaced. Anyway, this is a really good topic, but we're running out of time.
And I just want to say a quick note, if anyone still has more questions for me, please contact me at my email that you can see right here.
Cool. Can you post your email up there on the screen? Thank you very much. So anyway, thank you so much, Veronika. And that brings us to the end of the 29th episode of ISPI Live. Thank you all for watching and participating. If you're happy with the session, please like, comment, and share. ISPI Live right now is also ISPI.live. We have a website out of it, and please go there and visit. And if you have any questions, suggestions, please let us know. And if you know somebody that you think should be presenting at ISPI Live, please also let us know, even if self-recommending. If you have not joined ISPI yet, we welcome you to do so. Please visit our website at ispi.org. That is our home website. Next week, on April 1st, we will have Kent Clisby to talk about human performance and cybersecurity. So AI 3 weeks in a row. Last week, we have Dr. Stella Lee talk about the rise of AI in L&D. And this week, right now, we just have Veronika to talk about biases in AI. And next week, we're going to talk about the cybersecurity, our data security. It is very important. And Veronika also mentioned that during her presentation today. Also, another note, ISPI annual conference will be held next month, exactly 1 month away, at the beautiful colonial style Woodlands Hotel in Williamsburg, Virginia. And the date, save the date, month from now, April 23rd to 27th. Save the date, and we'll hope to see you there. ISPI Live is a weekly program every Saturday at noon USA Eastern Time, which is 9 a.m. Pacific. We thank Veronika Shestakova again for today's sharing, and Jennifer Romer today as the operator on the background. Thank you both. Again, this is George Gu hosting for you live from Shanghai, China. It is 1 a.m. here. Thank you all for your support. Thank you all for watching, and see you next week. Have a great, super weekend. Thank you.